Going further into giving the possible exponential generating function and its equivalent sequence for situations involving exponential notations just like this, we are just going to use the previously defined forms and previously provided identities in order for us to show the equivalent generating function for this and probably some implications if there are any. We have here the sum, okay, of e to the power of x and e to the power of negative x to be divided by 2. Okay, before we start with that, we know that e to the power of x is actually the power series with x to the power of r over r factorial, where r starts from 0 to positive infinity. We know that to be true. And if we are going to expand that, we will have here 1 plus 1, you have x to the power of 1 over 1 factorial plus, sorry, still 1 x squared over 2 factorial plus so on and so forth until you will reach 1 times x to the power of r over r factorial. Okay, so this is its equivalent form. In simplified form, you have 1 plus x over 1 factorial plus x squared over 2 factorial plus so on and so forth until you reach again x to the power of r over r factorial. Okay, that's for e to the power of x. E to the power of negative x was already shown in the previous video. Please try to review that. It's actually equivalent to the summation of negative 1 raised to the power of r, x to the power of r over r factorial as r starts from 0 to positive infinity. Again, if you're not yet convinced with this, try to view the previous video because we already shown the other equivalents of e to the power of negative x in terms of this power series and its equivalent exponential generating functions. So we'll have here for the first term negative 1 raised to 0, x to the power of 0 over 0 factorial plus negative 1 raised to 1, x to the power of 1 over 1 factorial plus negative 1 squared, x squared over 2 factorial until you reach here negative 1 raised to r, x to the power of r over r factorial, which would give us a simplified form of simply 1 because that's all 1. And if you're minus, because it's negative 1 raised to 1 minus x over 1 factorial, then you have here plus, this is positive now, x squared over 2 factorial. You would expect negative next until plus negative 1 raised to the power of r, x to the power of r over r factorial, alternating signs between the terms. So with this now in mind, take note that our notation is e to the power of x plus e to the power of negative x and then dividing into 2. Just for the numerator alone, e to the power of x plus e to the power of negative x will have this set minus or plus this set. So you have here 1 plus x over 1 factorial, okay, plus x squared over 2 factorial plus until x to the power of r over r factorial. Okay, that's plus this group 1 minus x over 1 factorial plus x squared over 2 factorial plus, sorry, again it's minus there. If there exists x cubed minus over 3 factorial, it's minus, so on and so forth until you have here plus negative 1 raised to r, x to the power of r over r factorial. Okay, removing the grouping symbol, you will have here 1 plus x, okay, over 1 factorial plus x squared over 2 factorial plus dot plus x to the power of r over r factorial. And then let me try to write it vertically. You have 1 minus x over 1 factorial plus x squared over 2 factorial minus again and plus here negative 1 raised to r, x to the power of r over r factorial. With that, look at the possibilities of cancellation. All the terms here with opposite sign will be cancelled. We don't know this yet, so we'll just stick to that. So we'll have here the form 2 plus twice x squared over 2 factorial plus, we're also expecting twice x to the power of 4 over 4 factorial and so on and so forth until you reach here. Okay, so since we don't know what r is, so they may cancel, they may not. Let's simply leave it as it is with that. Now this is to be divided into 2, so we also simply divide. Then if we're going to divide this into 2, because that's actually our entire expression, dividing that expression into 2, we would know the following results now. We have 1 plus 1x squared over 2 factorial plus 1x to the power of 4 over 4 factorial plus so on and so forth. But we would see that we include here the degree of term which are even in terms of exponents. Okay, so on and so forth. Its equivalent sequence is actually identified as this manner. 1, we don't have x1, 0, 1 for x squared, 0 for x cubed, 1, and so on and so forth, alternatingly. Now, what does this tell us? If we talk about a certain situation, especially if arranging or our permutations of how many that would be in arrangement pertaining, say, for example, if it's a multi-set, this tells us that the possibility of choosing the same set object once is not possible here. The possibility of choosing the same the object 3 times is also not indicated here. We can actually get the possibility of not choosing the said object, but choosing it once, thrice, and odd number times. It's not possible here. Only that it is possible to be chosen. Again, it's possible not for it not to be chosen, for it to be chosen 2 times or twice, for it to be chosen 4 times, in all the even number situations. Hence, if you have a same example of this one, if we are to see this later on in future examples or solutions, we would know that this will allow the certain object to be chosen in even number times, together with the possibility of not including that, but the odd number times is not possible here. So please take note of that as we will go and proceed to other examples later on. Thank you very much for watching.